So how do we do that? Well, there was originally something called the 8-point algorithm. It was done by, I think that was done by Christopher Loggett Higgins, and for a while it got sort of a bad rep because people thought it was very unstable, and that's why I put down that it was the infamous 8-point algorithm. Now, you might say, well, why can I do with just 8 equations? I've got 9 unknowns. Well, remember, p f p prime equals 0. I can scale the f any way I want, which means, for example, I could set that last value to a 1. Not a very good way of doing things, but it does mean that if you gave me just 8 points, I'd have 8 equations, and because I set the last one to 1, I would have 8 unknowns, and I'd be able to solve it. If I have more than 8 equations, right? So then I've got this, let's suppose I've got n. So I've got n equations with 9 values that are homogeneous. Have we seen that before? Yes. Remember when we solved very early on when we were trying to solve for the total calibration matrix between the world and the image, and we had the M matrix, and we said, well, there's 12 elements in here, but there's not really 12, right? There was really only 11, but if we used a whole bunch of points, we talked about you could set one element M to 1, but that wasn't such a good way. What was a good way? The SVD, remember you've got this A times M equals 0, or in this case, A times F equals 0. You take A transpose A, take the singular value decomposition, or you just find the eigenvectors, and you pulled out the eigenvector with the smallest eigenvalue. We've actually seen this now 3 times. I did it explicitly for you in the very first example, so you can go take a look at that. But that's how you solve it. And by the way, you would typically use more points than just 8 or 9, or you use however many points you have. So you solve this. And what happens? Well, your point matches aren't exact, are they? No. So you solve this, get an f. With an f, I can draw some epipolar lines, right? And if I used, and these numbers were meant to represent coming from that picture, I would see this, okay? And that's technically called a mess, all right? Because you'll notice that the epipolar lines, they're not all intersecting at that single point, are they? No. Why not? Well, I'll tell you.